The marker signal is very useful to synchronize your generated signal with an external instrument like an oscilloscope or a device under test. The AWG5000 has a marker output signal that updates with the same sampling rate of the analog channel, so 6.16 gigasample per second. With the marker page, you can modify the marker behavior, the skew with the analog channel and its voltage level. Now we will enable the marker signal and we will program it in custom pattern mode. The waveform editor allows you to draw the shape or the transition of the marker signal, and you can synchronize it with the analog channels that are created in the first two rows of the editor. The waveform list contains all the waveforms that are available in your instrument. The red ones are the predefined waveforms. They have been created by the factory and they can be edited by the user. You can also add new custom waveform to the list in two ways. By pressing the import button to import the waveform point in TXT format, and using this method you can create the point through a third-party software like Python, MATLAB or LabVIEW, and then you can import them easily in the list. The second method is by pressing the Edit button to open the AT waveform editor to edit or create a completely new waveform. The waveform editor is part of the standard software package, and you can edit at the same time the two analog waveform and the digital lines. The analog waveforms are made by segments that can be appended one after the other. In this case we have one segment, and each segment can be made by one or more components. The components can be added, subtracted and multiplied together. Now we are going to create a new analog waveform, and you can select using this drop-down list from a basic waveform like sine, cosine, triangle. Let's select a sawtooth in this case, and let's change the number of cycles to 4. Now I'm going to change the amplitude to 1 volt and press the OK button to confirm. On each waveform you can add effects like noise or filter. You can select a portion of the waveform, press the noise filter button, and you can add a filter, a noise before filter, or a filter before noise. Let's add some noise. Select a Gaussian noise. And let's type the standard deviation. You can edit using the digital waveform editor, the digital lines. You can set the waveform to 1, make a counter, make a clock, and so on. And at this point, you are ready to save your waveform. You can save it as a zip file or save it directly in the waveform list. Let's type the name of the waveform that we have been created. And press the Save in the Waveform List button. At this point, the waveform will be available in the TrueArb software. As you can see now, it is in the waveform list. And it is available to insert it in the sequencer. Okay, so let's press Run to start the generation. The last section of the settings is the triggering section. You can select different trigger sources, like for example trigger input 1 or trigger input 2, the timer, or trigger buttons, that means a software trigger. You can set the threshold, in this case 1.65 volt. And you can set the sensitivity edge as rising edge, falling edge, or both edges. The input impedance of the trigger, that can be 50 ohm or 1 kilo, and the mood, that can be fast or slow. The RF mode allows you to use the AWG for application related to RF wireless for communication and defense, and for quantum computing experiments. Press this button to switch from baseband mode to RF mode. In this mode, the instrument works at 12.32 GHz, and there are two possibilities: RF single carrier or RF double carrier, where you can set one or two different carriers in the range of 0.6 GHz. As you can see from the channel settings, you can set different parameters that are related to the carrier. For example, the amplitude scale, the skew, and the carrier frequency. You can set it in the range of 0 to 6 GHz. As you can see from the sequencer, you need to set two different waveforms for each entry. The first one is called I0, and it is internally multiplied by a sine of F0, while the second is called Q0, and it is internally multiplied by the cosine of F0. At the SMA output, you will get a RF modulated signal with a carrier of F0 in the range of 0.6 GHz. Now we will create a 16 QAM signal starting from the I0 and Q0 baseband signals. We will import two waveforms called I0 and Q0 from TXT points. At this point, we have to just insert the two baseband signals in the sequencer entry 1 and press the Start button to start the generation. As you can see from the oscilloscope, we are generating an RF signal without needing an external up converter. We can change now some runtime parameter, like the amplitude scale and the skew, to add some impairments to our RF signal. The Active Technologies arbitrary waveform generators have a full set of SCPI commands that can be used under Python, LabVIEW, MATLAB, C++ or .NET languages. The LAN, GPIB and USB TMC interfaces combined with the SCPI commands allows you to control by remote the instrument and build automated test and measurement banks. Press the remote button to have access to the remote control panel of the AWG. At this point, your instrument is capable of receiving the SCPI commands. Press the license button to check the installed licenses. The AWGs have several options depending on the selected model that can be, for example, digital channels, high voltage, waveform memory, or RF mode capabilities. You can upgrade your instrument also after the purchase, preserving in this way your investment during the years. The calibration and diagnostic page allows you to automatically calibrate certain parameters of the arbitrary waveform generator. And moreover, you can also perform a self-test to check if all the components of the instrument are working properly.